Hello, this is Mrs. Ward. What I'm going to cover today is taking the derivative using an implicit form, or otherwise known as implicit differentiation, instead of doing what we have been doing, which has been the explicit form, where we do explicit differentiation. So up until this point, we've had equations where we have y on one side by itself and all the variables on the other. And when we take the derivative of y in terms of x, we write dy dx, and then we write what the derivative is. Now what's going to happen is I'm going to have the x and the y on the same side, and I'm going to have to take the derivative in terms of y, the derivative of y in terms of x. You will notice that these two equations are exactly the same. They mean the same thing. But sometimes you cannot rewrite an equation in terms of just y, so that's why we're learning how to do the implicit differentiation. So the guidelines for doing these is you should differentiate both equations with respect to x. If you can, I like to put y on one side by itself and everything else on the other. Sometimes you can do that, sometimes you can't. Then once you take the derivative of both sides, you're going to separate the ones that have the dy dx attached to them on one side and everything else on the other. And then you're going to treat this dy dx. You're going to treat this as though it were a variable, and you're going to solve for that variable. And I think it's just a lot easier if we go through one so you can see a little bit more about what I'm talking about. So I have this first one where I have x squared minus y squared is equal to 16. You should recognize that shape. The conics have not gone away. That is an equation of a hyperbola. And eventually we will have to graph these when we're taking the derivative, so keep that in mind. You can't forget that knowledge that we learned. I'm going to solve this for y squared, so I'm going to have x squared minus 16 is equal to y squared. And then what I'm going to do is I am going to take the derivative. So the derivative of x squared is 2x. And I could write I'm taking the derivative of x in terms of x. But if I have the same thing written over the same thing, so in this case, I have dx written over dx. That's always equal to 1. And that's why I don't bother to write it wrong. And that's what we've been doing so far. And I just wanted to make you aware of that's what you were doing. You probably didn't know you were doing it. Then the derivative of 16 is going to be 0. The derivative of y is 2y. But I have to remember I'm taking the derivative of y in terms of x. So I'm going to write dy dx. Then what I have left is I have 2x is equal to 2y dy dx, and then you're going to treat this as though it were a variable, and we're going to solve for this. In order to solve for this, I would have to divide both sides by the 2y, so that's what I'm going to do. And when I divide both sides by the 2y, I'm going to end up with x over y is equal to dy dx. So that's one where I can solve for y by itself, for y on one side by itself, and everything else onto the other side, and so I have a very simple equation to solve. The next one is going to be a little bit more challenging, because when I go to take the derivative, since I have the x to the third, y to the third, those two variables are being multiplied, I'm going to have to remember that not only in the implicit differentiation, I am going to take the derivative of y in terms of x, but I have to also use the product rule. So we're going to go ahead and use the product rule. And I'm going to say, I'm going to take the derivative of x to the third, which would be 3x squared, and I'm going to leave the y to the third alone. So I'm going to do plus, leave the x to the third alone, take the derivative of y to the third, so that's going to be 3y squared, but I took the derivative of y in terms of x. So that's all this, what I've written here, all this is taking the derivative of this. Now I'm going to continue on with the equation because I have to take the derivative of everything. I'm going to have the minus sign. The derivative of y would just be 1, but I'm going to write dy because I'm taking the derivative of y in terms of x. And that's equal to, the derivative of x would be 1. Then I'm going to look for anything that has the dy dx term attached to it. So in this case, this is my dy dx, dy dx. I'm going to leave all that stuff on one side by itself. Everything else I'm taking over to the other side. So when I do that, I'm going to multiply these while I'm here. So we have 3x to the third y squared minus 1. And these are the things that have the dy dx attached to them. What does not have the dy dx would be this 3x squared y to the third. So I'm going to take that over to the other side. So I'm going to have 1 minus 3x squared y to the third. To solve for dy dx, I'm simply going to divide both sides by what I'm multiplying by. So we'll divide by 3x to the third, y squared minus 1. So my final answer, the derivative of y with respect to x is going to be 1 minus 3x squared y to the third over 3x to the third y squared minus 1. Now you're going to have some problems where it's going to ask you to show that the explicit derivative and the implicit derivative are the same thing if you just go about it 2 different ways. So I've given you a nice little ellipse here. I have 9x squared plus 16y squared is equal to 144. And I'm going to follow these steps. The first thing says find 2 explicit functions by solving the equation for y. So the first thing I'm going to do is solve this equation for y, subtract 9x squared from both sides. We have 144 minus 9x squared. Then I'm going to divide both sides by 16. 144 minus 9x squared divided by 16. And then I'm going to take the square root. And remember, when I take the square root, it's going to be plus or minus. So when I take the square root, it's going to be plus or minus the square root of 144 minus 9x squared. And that's going to all be over, and the square root of 16 is 4. So those are my 2 equations. One is going to be plus or positive square root of 144 minus 9x squared over 4, and the other one will be a negative square root of 144 minus 9x squared over 4. The second thing says it says sketch the graph. So going back into my mind, I'm going to remember how to sketch the graph. I'm going to get graph paper. I will be right back. Okay, I have my graph paper, and now I am going to graph this. I should recognize it as an ellipse. I am going to remember to put in standard form. All ellipses have to be equal to 1, so I'm going to divide everything by 144. When I do that, I'm going to have x squared over 16 plus y squared over 9 is equal to 1. Just a refresher course, when I graph this, remember my center is at 0, 0. My major axis, because the larger numbers with the x, my major axis is going to be on the x. I'm going to move 4 units to the left and the right because of the 16. So 1, 2, 3, 4, 1, 2, 3, 4. And then for my y vertices, I'm going to move up and down 3 because the square root of 9 is 3. 1, 2, 3, 1, 2, 3. And that's the graph of my ellipse. So that was part B, graphing the ellipse. The next thing it wants me to do is it wants me to differentiate the explicit function. So I'm going to grab the function the way it's written, and I'm not going to solve for y this time. I am just going to take the derivative the way it is. So I'm going to just copy it down, and I'm going to take the derivative. I probably would solve for y. So since I'm going to solve for y, I'm going to have 16y squared is equal to 144 minus 9x squared. Divide. Oh, what am I doing? Oh no, I'm right. Why do I doubt myself? I'm not dividing by 16 because that would be me solving for y. I don't want to do that again. I've already done that once. Now I'm going to take the derivative. So when I take the derivative of this 16y squared, that's going to be 32y. Took the derivative of y.
Key call extension is 1123.
Take the derivative of 144. That will be 0. The derivative of negative 9x squared will be negative 18x. Solving for dy dx, I'm going to have dy dx is equal to negative 18x over 32y. When I put in lowest terms, it's going to be negative 9x over 16y. And then I look at it and I say, well, that doesn't look at all like what I had up here when I took the derivative. It doesn't. So then I ask myself, well, here when I take I have this y. Where'd it go? I have this y, and I didn't have that y before. So what I have to do is I have to substitute in what y is equal to. So I have to go back up here to what y is equal to, and I have to substitute that back in. So we're just going to do the positive one. Well, you know what, we'll do both at the same time. We can do it. I have faith in us. So this is negative 9x times 16, and then y, remember, was equal to plus or minus the square root of 144 minus 9x squared. Oh, almost forgot. I'm going to go back up here. That's all over 4. So I'm going to put this all over 4. Now here the 16 and the 4 will simplify, and I'm left with negative 9x over plus or minus, and then that'll be 4 times the square root of 144 minus 9x squared. And so all this negative sign will do is technically it's going to change this from plus minus to minus plus. It's still the, and we can see that that's going to be the same answer that I got when I took the derivative using that. Okay, moving on. Trying to move on. All right, the next one is I just want to show you trig one because I know how you like to freak when you see trig. So I'm going to have to use the product rule. So I'm going to have 2. I'm going to leave the sign alone. Take the derivative of cosine y, which derivative of cosine is negative sine y, and then I'm going to do dy dx. Then I'm going to have a plus. Here's that 2 again. The derivative of sine will be cosine. And I don't have to write dx over dx, it's because it's understood, times the cosine of y. Now, because these are different variables, I cannot combine them. So, and this is equal to 1, so this is equal to 0. So what I'm going to do is I'm going to put 1 on the other side, so I may take all this over to the other side. This has a dy dx attached. I'm going to leave it on this side. Why I'm at it, I'm just going to bring this negative sign up in front. So we have negative 2 sine x sine y dy dx is equal to negative 2 cosine x cosine y. When I solve for dy dx, I am going to end up dividing both sides by dx. I'm going to end up dividing both sides by what it's being multiplied by. So in this case, I'm going to divide both sides by this negative 2 sine x sine y. But I'm going to put the letters, matching the letters underneath. Oh, it's fine. Negative 2 sine x cosine y. So dy dx is going to equal negative 2 divided by negative 2 is 1. And then the cosine x, cosine over sine. Oops, I made a mistake. That should be sine. Sine. Cosine over sine is cotangent. So I'm going to write 1 cotangent x, cotangent y. And that's the derivative of y in terms of x. Now, when we do implicit differentiation, we can still find the derivative at a given point. It's still the same idea. You find the derivative, and up until this point, we found the derivative. Then we substitute in x to find the slope of that line at x. We're still going to do the same thing, but sometimes I have a y in my derivative, so I'm now going to have to sometimes use that negative 1, the y coordinate as well. So this is a very simple one. I'm going to use the product rule. I'm going to leave the x alone, take the derivative of y, which would be 1 dy dx, plus take the derivative of x, which would just be 1, and then leave the y alone, is equal to 0. So now I'm going to have x times dy dx is equal to y, negative y. And then so dy, the derivative of y in terms of x, is going to equal negative y over x. So now when I want to find the derivative at that point for negative 1, I can find the derivative in terms of x at that point negative 4, negative 1. This is my x, this is my y, so in place of what, so I'm going to have the opposite of my y, which is negative 1, over my x, which is negative 4. And my slope of the tangent line at that point is going to be a negative 1 4. So sometimes you're going to have to use both the x and the y. The last thing I have to show you is I have to show you the second derivative. Remember, to find the second derivative, you find the first derivative, and then you take the derivative of the derivative to find the second derivative. To make this one a little easier, I'm going to put the y squared over there, the 16 over here, so I'm going to have x squared minus 16 is equal to y squared. Again, if I can put y on one side by itself, I'm going to do that. Now I take the derivative of x, which will be 2x minus 0, don't really need it, just thought I'd write it, is equal to 2y, derivative of y in terms of x. When I'm solving for the dy dx, I'm going to take 2x divided by 2y is equal to derivative of y in terms of x. And so my first derivative is going to be x over y. That's my first derivative. I'm going to write that. First derivative. Don't criticize my spelling. I'm sure I spell it wrong. All right, now here, to find the second derivative, I'm going to take the derivative of this. Again, I'm going to have to use the quotient rule, and I'm going to have to do it implicitly. So using the quotient rule, and I'm going to write myself a note, the second derivative of y in terms of the second derivative of x, just put those little square symbols, or you can do the 2 ticks. I think this is cleaner. I'm going to leave my denominator alone, take the derivative of my numerator. The derivative of x is just 1. Minus, leave my numerator alone, so leave that x alone this time, take the derivative of y, which would just be 1 dy dx. Don't have to write the 1, just show me what I'm doing. And this is all over the denominator squared, so y squared. So when I rewrite that, second derivative, I'm going to have y minus dy dx all over y squared. And remember, I did not take the derivative of that y squared. That is why I am not doing any dy dx with it. It's just g of x squared, so that's why it's just left alone. When I look at this, I have this dy dx. And in order to solve this, I need to substitute something in for dy dx. And if I go up here, I realize that that's my first derivative, that dy dx, and that was equal to x over y. So in order to solve this, and here's where fraction skills come in handy, I am going to put in x over y. So I'm going to have y minus x over y all over y squared. And this is still my second derivative. I'm just rewriting it. I substitute the derivative of y in terms of x, which is xy. In order to solve this, I'm probably going to, I don't know how you want to solve it. I know how I want to solve it, so I'm going to do it my way. Hopefully you understand. I need to get rid of this denominator. This is understood to be over 1. This is understood to be over 1. This has a denominator of y. So my least common denominator for both fractions is going to be y. So I'm going to multiply both my numerator and my denominator by y. So I'm going to multiply the top by y, the bottom by y. When I do that, I'm multiplying by 1, so I'm not changing my fraction at all. When I multiply this, that'll be y squared. So y squared minus, here the y's will simplify, so y squared minus x all over y to the third. And that is my second derivative. Okay, I hope this helps. You should have already gone over the homework and turned in the homework. You have a worksheet. So do the worksheet. The answers should be online. And then when I come back, we will review and hopefully have a quiz. All right, see you soon.